Welcome to qnawire.
This question is mostly associated with the crystal field theory. This question describes that there's a certain first-order transition metal that forms different colored solutions. 4 coordination compounds with this metal have the same coordination number, and when dissolved in water form red, yellow, green, and blue solutions. Further experiments reveal that 2 of the complex ions are paramagnetic, with 4 unpaired electrons and 2 are diamagnetic. So what can we deduce about the 4 different coordination compounds that are created? Well, according to the crystal field theory, building upon an octahedral complex, we can have energies of the d orbitals as being split, where 3 of them are lower in energy and 2 of them are higher. If the higher energy d orbitals are significantly higher, it can force all of the electrons into the lower energy state. When this occurs, we have all paired electrons and we have a diamagnetic species. So this must be occurring for 2 of the coordination compounds. This often occurs when we have negatively charged ligands, forcing this greater energy difference. With a greater energy difference, then higher energy photons are absorbed in order to transition an electron from a lower energy state up to a higher energy state. If higher energy photons, like blue and green, are absorbed, then the molecule, the coordination compound, is going to appear more yellow or red. So 2 of them must be like this, where we have negatively charged ligands, and 2 of them must be like this, a low filled or weak filled arrangement. In a weak filled case, we have electrons that could occupy the lower energies up in the higher energy, because the higher energy is very close in energy to the lower energy. This results in a maximum number, or this can result in a maximum number of 4 unpaired electrons, which is the case in this problem. So that must mean that this lower energy is low enough to cause 2 of the electrons that could be paired to be unpaired in the higher energy orbitals. If we have a lower energy, high energy d orbitals, then that means that there's less of an energy transition that occurs. So that means lower energy photons are absorbed. Lower energy photons, like yellow and red photons, if they are absorbed, then the blue and the green light passes through and the solution appears blue and green. This typically occurs when we have uncharged ligands attached to the metal. So it's likely that we have 2 negatively charged, or 2 coordination compounds with negatively charged ligands, resulting in a strong field, 2 of them with neutral ligands, resulting in a weak field, causing a red or yellow solution in this case, and a blue or green solution in this case.